All right, good afternoon, everyone. Any Spring developer in the room? Some of them, right? So maybe you're in the wrong room. But well, we'll try. So just a quick show of hands before getting started. Is anyone on Spring Boot 2.7 or below? Raise your hand. Don't be shy. Don't be shy. OK, good. What about Spring Boot 3.4? Running the latest and greatest. Wow. Pretty good, pretty good. All right, so my name is Sergi Almar. Everything I do is on Spring, so that's my world, right? So I spend half of my time doing trainings, half of my time doing development, and I also organize a conference called the Spring I/O in beautiful Barcelona. So if you're a Spring developer, that's the place to be. And Barcelona is not a bad place, right? So it's in May, so good weather, good food. So check it out, right? If you are a Spring fan, Spring enthusiast. So Spring Boot is moving fast, right? So we have basically a release every 6 months, like in Java. We have really new features, right, on both on minor versions and major versions. And if you take a look at the code base, we have a lot of contributions, right? So more than 1,100 contributors on Spring Boot itself, so really active community. And it's basically evolving really fast, innovating, right? So it's basically setting the pace, right? So little did I know in 2005 when I started with the Spring that this framework would still be alive 20 years later, innovating, right? And basically leading the space. So really good investment, and you should do it as well, right? Because it's a really active project and good project. So if we take a look at the latest versions, right? We had Spring Boot 3.2 in November 23, right? That was based on a Spring Framework 6.1. Usually, we have 2 releases using the same version of a Spring Framework, right? So 6.1 was used both on 3.2 and 3.3, right? So 3.3 was released last May, right, in 2024. And then Spring Boot 3.4, which is the current release, or was released in November 2024, right? So this release was already using the 6.0 Spring Framework, so basically getting all the latest bits from the Spring Framework. So we get like new stuff in the framework, new stuff also in the Spring Boot as well. So if we take a look at the history, right, of this 3.0 generation, 3.0 set kind of the foundation of the entire minor releases. And I would say that one of the main themes in Spring 3 was basically, the AOT support, which was a prerequisite for VM and having these native images, right, really important. And we'll see this trend of efficiency, right, over the different releases of a Spring Boot, right? Also, Spring 3 set the foundation of the observation API, which we're going to see that we have been improving this observation story over the different releases, right? Spring Boot 3.1 focus more on Docker Compose support, so you could actually have a Docker Compose YAML, and this would start the services when you would start your application and shut down the containers when you stop the application. We also have good support for test containers. And in Spring Boot 3.2, we continued with the efficiency story, right? So we saw the support for virtual threads if you're using Java 21, and also Project Crack for having like a faster startup. Again, in Spring Boot 3.3, one of the main themes was the support for CDS, class data sharing. So again, like evolving this efficiency story, right, from 3.0 until the current releases. And in Spring Boot 3.4, right, again, right, so taking the observability further with the structured logging and many other stuff that we're going to see. So we're going to focus on the last part of this roadmap, right? Where we're going to see some of the new features that have been added into the framework in case that you have upgraded but haven't taken a look at the new stuff, the new bits that you can use, right, with all these new releases. So if you're anywhere right below 3.2, right, all these versions are not supported, at least from the open source point of view. If you have a commercial support, then you are kind of safe. And if you are on the 2.7 branch, right, you have still some life until 2027 if you are under a commercial support, right? But the goal here is to basically keep upgrading and be on an active release, which is currently either 3.3 or 3.4. The best way to basically know when all the new bits come out is by checking the Spring Release calendar, right? So if you go to spring.io/projects and you scroll down a little bit, you'll see this calendar, which is synchronized with GitHub, and you can see all the projects, not only for Spring Boot, but all for the entire portfolio. And you can see all the versions that are going to come out next. All right, So now into some of the features that we have in those releases of Spring Boot. And we'll start with observability again, right? So Spring Boot 3.0 had a really good story in terms of observability, right? Which has been evolved right over these releases, right? And yeah, Spring Boot had a really good support for logging since the very beginning. It supports different frameworks. And by default, we're going to use SLF4j with Logback, but we could use other frameworks. Feel free to use any of the supported frameworks in a Spring Boot. But you're going to see that if you enable tracing right in the latest releases and you basically log something, you'll see the trace ID and the span ID automatically added into the log. So previously that was also available, but you have to define the log pattern yourself. So now out of the box, you're going to get all these automatically, so you can correlate those logs with the traces, right? And you can go from logs to traces in your tracing tool or log tool. But these text logs are great, right, for humans, so we can read it, right? But if we send these logs into a logging system, well, it needs to figure out what's basically each of these parts of the log. So it needs to figure out that this part is a trace ID, this part is a span ID, and we end up having some patterns or configuring some patterns in those logging systems to basically help parsing these log files. So that's why in Spring Boot 3.4, we have now support for structured logging. So we're going to go from these text-based logs into this structured logging, right, which looks like this JSON, and we have support for different formats. So we have support for Elastic Common Schema, Graylog Extended Log Format, and Log Stash, so you can decide which one to use by simply adding this property in your application.properties, and we can enable structured logging for files or for console or for both, right? So you are going to then have the structured log. We're going to see easy, right? The log level, the message, the trace ID, right? The span ID. This will help, right? The logging tool to identify each of the parts of the log. So much better, right? To be explicit and help all these tools. So when we talk about observability, we talk about logs, metrics, and traces, right? So we have a good story on metrics, right? And if you actually access the metrics endpoint on a Spring Boot Actuator, you will see all the available metrics on your application. You'll have metrics on the application itself, the file system, task executors, HTTP requests, and so on and so forth. But the thing is, this foundation is used in all the other projects in the portfolio. So if you take a look at the metrics endpoint, you see that we have some Gen AI metrics, right? So we use a Spring AI, which is one of the latest projects added into the portfolio. You will see that these projects already leverage, right, all these observability API, and you'll have all the metrics available right away on your Spring Boot Actuator that you can then use to send into an external tool. And you can build graphs like this. In this example, we have a graph of a Spring AI application that shows you, I don't know, the consumed tokens, the latency of your models, and so on and so forth, which is really nice, right? So having all this out of the box just by adding Spring Boot Actuator, right, and adding your project, and getting all these metrics on a particular endpoint. The same applies to tracing, right? So all the efforts that have gone to tracing are leveraged by all the projects in the portfolio, right? So in Spring Boot 3, we are now using a micrometer tracing. In Spring Boot 2, we were using a Spring Cloud Sleuth, right? So no more Spring Cloud Sleuth. Now we come with a new observability API and the micrometer tracing. So this is basically an abstraction layer on top of either Brave or OpenTelemetry. And again, right? So all the projects in the Spring portfolio will be using observations, right? And this will create traces. So if you have an HTTP request, for instance, this will create trace ID, but then when you go through Spring Security will have its own span IDs. If you use Spring AI, when you call the model, you'll also generate another span ID, and so on and so forth, right? So you'll have a clear picture on the traces of your application, so you can then use a tool like Tempo, for instance, to visualize the interaction between your application and other systems or different components of your system, as we see here, right? So really cool to have this visualization, right, for your particular request. So good support for logs, for metrics, and traces, right, with a story that we started, right, with Spring Boot 3. Now, another major feature, I would say, and continuing with the efficiency story, is virtual threads, right? So Java 21 now comes with virtual threads, and in Spring Boot we have really good support as well. So just by adding a simple property, this Spring Threads virtual enabled equals true, we're going to switch to virtual threads. So we can go away with this limitation of per request threads, right, and have a better scalability. Of course, that works if your application has a lot of I/O operations. It doesn't work as well if you have these CPU-intensive operations. But you'll see that just by adding this line here, your embedded servlet container will be configured with virtual threads. And if you go to these auto-configuration classes from Spring Boot, you'll see that, for instance, if you use Tomcat, this will be configured to use virtual threads. If you use Jetty, this will also be configured to use virtual threads. And if you use Undertow, which is one of the latest additions in terms of virtual thread configuration, it will also be configured to use virtual threads. But not only the embedded servlet container, so other components in your application will also use virtual threads, like the task scheduler. But what if I use Kafka, for instance, right? So these Kafka listeners will also be configured, right, to use these virtual threads. And also Rabbit listeners. And in Spring Boot 3.4, we also have support for WebSockets. So if you use WebSockets, those are going to be configured also with the virtual threading model, right? So really easy, right? And you'll see just by one simple property, we're going to get all these components configured by using virtual threads, right? And even if the support was introduced in 3.2, the story has evolved, and along the way, we have enabled, right, the different components like Rabbit listeners, Kafka listeners, and so on and so forth. All right, so more things that we have, the client support, right? So I guess that you're familiar with things like the REST template, right? And the JDBC template, those are great, but those components are like really old. And we have a lot of templates in Spring, right? So we have the web service template, the Kafka template, and many other templates, right? And as you can imagine, these APIs have been around for a long time, right? And we have been adding, right, a lot of new methods. We have overridden methods. A lot of methods have been deprecated. So the API was not that clean, and it asked for a rework, right, of those APIs. So that's when the REST client and the JDBC client came into play, right? So the REST client is basically a synchronous HTTP client, but having a fluent API. So if you're familiar with the web client, which is basically this async client, which basically uses the reactive types, well, it's good, but at the end of the day, we have to learn about what a mono is, what a flux is, right? If you want to simulate what we can do with the web client, but in a synchronous way, right? In a synchronous way, we can use now the REST client. And this REST client is now auto-configured with the underlying client. You can use HTTP components, Jetty client, Reactor Netty, JDK, simple JDK. And this will be configured based on what you have in the class path. So if you take a look at the code here, right? Creating a client is really simple. So you have the builder. This builder will be aware of all the configuration that you have in the application context. So if you have a, configuration for Jackson, this will be included as well. And you'll be able to define some common properties like the base URL. And notice that the usage of the REST client is pretty simple. It has this fluent API that will guide you through the operations. So REST client.get, we do a get request to a particular URL. We call that URL, and then we map the response into a particular class or record, whatever that is, right? So simplifying the REST client, right? So moving from the REST template into the REST client. Notice that internally, the REST client uses the infrastructure of the REST template. So we're not going away, right, from the REST template. It just happens that we have an abstraction on top that will give you a much better experience, right, than this Fluent API. And the same happens with the JDBC template, right? So we have the JDBC client that basically uses the JDBC template underneath, right? And it simplifies and uses this Fluent API. So now we can use this API to just say, I want to execute this SQL statement. I'm going to pass this parameter, and then the result should be mapped to this particular class, right? And give me an optional of that. So if we cannot get a speaker, then get an empty optional. Otherwise, give me the speaker. So these two additions into the framework have kind of inspired, right, other clients. So for instance, if you take a look at some other projects like Spring AI, right? So I'm not talking about the Spring Boot now, but the clients that we have in Spring AI has been inspired by the REST client and the JDBC client. At the end of the day, we're moving away from those templates, and we're embracing, right, those clients with a more or a better API, a more fluent API. So as you see here, we have a chat client which allows you to integrate with LLMs. At the end of the day, JDBC client allows you to interact with a relational database. REST client allows you to interact with other services. And the chat client allows you to interact with LLMs, right? So at the end of the day, it's kind of an integration problem that we're solving here with the same programming model. So you see that we have a builder the same way we had the REST client builder. We define some common properties like an advisor, which is nothing more than interceptor. And then we use the chat client with this Fluent API to say, hey, I'm going to specify a prompt. That's the user prompt, call the model, and then give me the response and map it into a book, right? A book could be either a class, record, as we see here. All right, so moving away and moving into this new type of clients where we have more fluent API, which is great, right? So it will give you a better experience, right, from a development perspective. All right, so if we take a look at the Spring Boot Actuator, I love a Spring Boot Actuator, right? So it's basically a project that you just add a dependency and you get a lot of information of your application, whether it's, I don't know, the environment that your application sees, whether it's the bins that you have in the application context, the metrics, the health checks, right? So everything is there, right? So things that you don't have to implement yourself, and you can then focus on the business logic. So in the Spring Boot Actuator, we have an endpoint called info, right? And this info is basically containing information about the application, but it's like a blank page where you can add anything, right? So you can add your own information, but there are something called the info contributors that will contribute it to this endpoint. So you can contribute information about, I don't know, the Java version that you use, the Git information, environment information, and there has been a couple of info contributors added into Spring Boot as well, which are the processor info contributor and the SSL info contributor. They will contribute information about the process and also the SSL bundles that you use in your application. So how do you enable all these? Well, just by adding these properties, right? So the ones below were already existing. We have actually these two extra properties that allow you to add this information into the endpoints, right? So about the process and the SSL bundles. But again, right? So you can add any information about the OS, environment, Git, Java automatically, and you can then also, right, implement your own contributors or add any information into the info endpoint. So that's basically what you're going to see if you go to /actuator/info, if you enable these info contributors, right? So the process is basically here on the left-hand side. You'll see that we have information like the CPU, I don't know, the heap and no heap about the memory. On the right-hand side, you'll see also the information about the SSL bundles that you use in your application, right? So you'll see here the certificates, you'll see the subject, you'll see the validity, so everything is exposed as your application information. So if you have been using Spring Boot Actuator, you might know that even the Spring Boot Actuator enables, right, a lot of endpoints. Those endpoints are not exposed to be consumed through HTTP, right? By default, only the health endpoint is exposed. So you have to explicitly expose what you want to consume, right? So you can do it by using the first property here, management endpoints web exposure.include. And in this case, I'm going to expose info, health, and loggers. Loggers is actually an interesting endpoint that allows you to check the log level of all the packages in your application, but also it allows you to change the log level at runtime without restarting the application, right? So previously, when you exposed an endpoint, right, you didn't have control over what you could do with those endpoints. So now this has been revisited, and we have another access model to those endpoints. So now you can specify, okay, I'm going to expose this particular endpoint, but this will only be read-only, right? So notice the second property, we're setting the loggers endpoint to be read-only, because we can actually send GET requests and POST requests to the loggers endpoint. So GET request to get the log level of a particular package, and a POST request to change, right? Or actually the pull request to change that log level, right? So when you actually do a POST request, right, you'll see that this doesn't work anymore, right? Because you are only allowed to do a GET request, right? So you can actually specify whether you want read-only access, unrestricted access, or no access at all. Other endpoints that have been added into Spring Boot Actuator, the SBOM endpoint, right? So you can actually expose the software bill of materials. And this could be interesting for compliance purposes, right? So let's say, hey, I need to comply with some security model, right? And I want to make sure that our application is using these particular versions of those dependencies. So you can actually expose the software bill of material. The easiest way to do it is by adding this plugin right here, the CycloneDX plugin that will generate a CycloneDX software bill of materials, right? And this will be already exposed right into a Spring Boot Actuator. So just by adding this plugin, the SBOM will be created, and this will be exposed then into a Spring Boot Actuator. Spring Boot Actuator will create an SBOM called application. So if you go to /Actuator/SBOM/application, you will see the software bill of materials. So you'll see that, well, we have a, that's actually huge, right? In our case, that's just the first part of the output, but you'll see, well, we have this component, and you'll see that the publisher is this one, the group and the name is this one, the version is this one, and so on and so forth. So that it will give you like the a vision of what you have inside the application, a real vision, right? So you don't have to have an Excel file with all the different artifacts. You can just ask the application, what do you have, what are you using, right? And you can make sure that you are complying with the guidelines that you want to comply with. Another endpoint that has been introduced is the scheduled task endpoint, right? So if you have a scheduled task, like running, or actually methods without the scheduled, either defining a current expression, a fixed delay, or a fixed rate, now you're going to get all this information exposed right into an endpoint. So you can actually go to /Actuator/scheduled task, and you'll see which scheduled tasks do you have and how frequent they're running. So in that case, I have an expression. It's going to run every 10 seconds. What's the next execution time, and when was the last execution time? If the last execution completed with an exception, you're going to see the exception right here as well, right? So you can actually monitor whether those executions were running successfully, were running with an error, right? And you'll see that exposed right into Spring Boot. So Spring Boot is a really good project, right? That will give you all this information about your application at runtime without even doing anything. All right, another interesting thing is about packaging, right? I love build packs. So how many of you are packaging into containers here? All right. So we as developers, we have to take care about a lot of stuff, right? And creating a production-grade container is hard, right? We have to understand how caching works, right? So how all the layer caching works. We have to create maybe a user because we don't want to run the container as root. We have to actually follow a lot of best practices. So in Spring Boot, we can leverage build packs to create the production-grade containers, right? So without doing anything, you'll get a production-grade container that follows all the best practices. So now, we have some improvements right, on this container generation if you're using build packs. So now, if you create a container using a Spring Boot 3.4, this will use this tiny builder. Right? So this has changed between 3.3 and 3.4, and that means that you're going to get a smaller container. Right? So notice that we have here a reduced size right, by 23% just by going from 3.3 to 3.4. So this is basically the same application. As you see here, the 3.3 version is 351 megs, and just by upgrading to 3.4, we get this container reduced to 270 megs. Right? So this is basically because we are changing the builder to create the container, and of course we have to remove something, right? So one side effect will be that your container doesn't have a shell anymore, right? Because well, we have to trim from somewhere, right? So we have to basically shave some megs from somewhere, right? But it's good to have a smaller containers. And another addition is the support for RM containers, right? So previously that was not possible with build packs, but now by adding a particular property, which is this image platform, into the command, you'll be able to generate an ARM compliant container. So notice that Maven Spring Boot build image is the command that we use to create containers that will use build packs underneath, and we now pass this extra parameter called image platform, specifying the platform that we want to target, like AMD64 or ARM64. This also works with native images, by the way, so you can actually enhance that and say, hey, I want to create an ARM container with a native image. So what do we need to do to make this happen? Well, we just specify a particular property, a buildback property, right, in the XML, and that's about it, right? So that's the only thing that we need to do. So really, really straightforward. Now, into again, right, so going back to the efficiency theme, right? Spring Boot 3.2 enable crack support, right? In 3.3, we have CDS support, so class data sharing. So the main goal of CDS is basically to have a faster startup and also, right, to consume less memory. And this is not like running native images, so native images are going to be like much better in terms of startup time and consuming less memory. But the good thing is that you are able to stay in the JVM, right, by using CDS. So native images might not be for everyone. We have some restrictions, so we don't have. Actually, we cannot go for native images without any restrictions, right? And well, you might not want to have these trade-offs, right? So CDS might be something that you might leverage, right, to increase, right, this. Or actually decrease the application startup time still using the JVM. So how is CDS working? Well, the thing is that we're going to, or we'll need a training run. So that means that we're going to start the application, but we're going to exit the application automatically. So with this, we can generate the CDS archive. That's where we're going to store all the classes. And then when we have this production run, we're going to use the CDS archive created by the training run, and this will give us a better startup. So the good thing is that we have, right, a good support in Spring Boot now. Right? Before creating this archive, a good practice would be to explode the jar. Right? So when you create a jar file with the Java in a jar, right, this jar file might not be the best way to run an application in production, right? Because we have some penalties, some startup costs when running or loading, right, classes from the nested jars. So what we can do is to explode the jar, and then we have a simple command like this one here, right, with no extra tools, that allows you to explode this jar. Right? So if you run this command, Java minus the jar mode equals tools minus jar and your jar file, and you basically extract the jar file, this will create a jar file with your code, right? And then a separate directory libs with all the dependencies, right? So if you run this jar, this will run more efficiently, right? And that means that it will start much faster. All right, so that's going to be the first step that we're going to do. Next step is going to be the training run. Right? So we're going to basically start the application and exit the application automatically so we can create this CDS archive. So the way to do it is by adding these two extra properties when you start the application. We're going to add this archive class at exit. That's basically the location where we're going to create the CDS archive. And then the second parameter is this Spring context exit on refresh. This will basically tell Spring to exit the application when we, right after we start it, right? So we just start the application for the sake of creating the CDS archive, right? So that's going to be the training run. Now, when we run the application, we'll add this extra property, the shared archive file. So with the CDS archive that we just generated, we start the application, right? But we have some constraints that we have to meet, right? So we're going to use, or we must use the same JVM. We also have to use the same class path. Right? So these are the two constraints that we have to meet to run CDS. Now, if we compare the startup time, right, of running a Spring MVC application, for instance, you'll see the blue line is basically an executable jar. So this is basically the jar that you get when you package your application, right? So you do Java in a jar. That's basically what you do here. If you explode the jar, if you extract it, that's going to be the red line here, right? So you see that we shave some startup time. But if you extract the jar and you enable CDS, you'll see that we go like pretty down, right? To no, not half, but almost half. But the good thing is that you can actually use or enable AOT plus CDS at the same time, right? So you don't have to go native to use AOT. You can actually use AOT on the JVM, right? So you can extract the jar and enable AOT and CDS, and you'll see that you go less than half, right? When it we talk about the startup time, is still on the JVM, right, on the same JVM. And we take a look at the memory, right, that you see here, that the executable jar is 211, and if we go on the other end, right, that when we extract and enable AOT and CDS, we get maybe more than 25% of memory decrease, right, which is pretty good considering that we are still on the JVM, right, so without doing much. All right, so I guide you through, right, the steps to enable CDS, and it might feel like this is a lot of things to do, right? So we have to explode the jar, right? We have to start the application in order to create this CDS archive, and then we have to use this CDS archive to start the application, still with the same JVM, the same class path. The good news is that if you use build packs, right, you can actually let build packs do it for you, right? So build packs can perform the train run for you. It can create the CDS archive, and then it can add the CDS archive into the container and run, right, your application with this CDS archive, right? So you don't need to do all these steps yourself. You basically leverage build packs, and it will create a production-grade, right, container enabling CDS, and you basically don't do anything, right? So you basically leverage build packs. Again, the only thing you have to do is to basically enable or pass this build pack property, build pack JVM CDS enable equals true, and this will instruct the build packs, right, to basically do all the steps to enable CDS, right? So pretty good, right? So just one property, and we get the job done. So build packs are great, right? Not only for complying with all the best practices, but get a better startup time, right? So there are only benefits by using build packs. So don't create your Docker files. Just use the built-in build packs, which are great. More things to cover, right, on the testing side now, right? Spring has had a feature, right, for a long time, which is called bin definition overriding, right? So where you can have a definition of a particular bin, and you can override this definition on another class, for instance. Spring Boot disables that feature since I think it's Spring Boot 2.2, right? So a long time ago, right? Because it's kind of dangerous, right? And we don't want that to happen in production. You might have a bin, and then someone else overrides that bin without you knowing. So this is disabled, right? But there's a legit use case, which is testing, right? So what if I want to override a particular bin in test, right? So we cannot use bin definition overriding. That's disabled. We could enable it, right? But that will have the side effect of having this behavior in production as well. So now we have a bin overriding infrastructure, right? New infrastructure that you can leverage, right? And we have three notations that allow you to override bins inside the application context. So these are test bin, Mockito bin, and Mockito spy bin. So the first one, test bin, allows you to override the bin inside the application context by defining a static method, which is a factory method. You can say, hey, I want to override this particular bin in the application context, and here's the way to create it, right? So if it's not in the application context, it will be created anyway. It won't overwrite anything, but you'll have it in the application context, right? So you want to have it in the application context. And this is basically done as easy as this, right? So you annotate a class with a test bin and say, hey, I want to create a test service. And then you'll need a static method with the initialization code. That's going to be your factory method that the test context framework will leverage, right, to create that bin and override any bin in the application context of that particular type. The same applies to Mockito bin, right? So before, we already had a mock bin annotation, right? In Spring Boot 3.4, the latest release, that's deprecated in favor of Mockito bin. This is not just a change in the name, right? So internally, it behaves differently because it's using the bin overriding infrastructure, right? So the same that we have seen for the test bin annotation. So now, again, we can annotate a class or interface with Mockito bin, and that will create a mock and will register it inside the application context. We can do it by type, like on the left-hand side, or we can specify the bin to override by name. So on the right-hand side, we specify explicitly the name of the bin, so this will be overridden, right, in the application context. So in the same fashion, we have Mockito spy bin, right? And this will create a bin of a spy of an existing bin. So it will wrap an existing bin so you can monitor it, right? And it works the same way. We annotate just a class with a Mockito spy bin, and underneath it will use the bin override infrastructure that we were talking about. So we take a look at the code, right, of these annotations. You will see that all of them are annotated with a bean override and delegate to a bean override processor, right? So the test bean will delegate to the test bean override processor. The Mockito bean will override to the Mockito bean override processor, and the same applies to the Mockito spy bean. So that means that it's an infrastructure that you can even extend. You can even extend the behavior and how you want to override beans on the application context from a test perspective, right? So this has been redesigned from the ground up. More things on the testing side, right? So if you're familiar with MockMvc, right? MockMvc is a really nice class, right, to test the endpoints of your application, right? This will give you like a lot of methods to simulate, get requests, post requests, and record expectations. This class uses Hamcrest, right, for the matchers, right, and basically check the responses. And if you have used that class before, when you create, for instance, a GET request, right, you'll have to define a static import and so on and so forth. So the AssertJ support has been requested for long, right, and now we have a new class called MockMvc tester, which relies, right, on MockMvc, right. So the same happened with the JDBC template and the JDBC client and so on and so forth. So we're leveraging all the infrastructure that we have, but we now have support for AssertJ. Right? So you can test your MVC endpoints, for instance, using AssertJ, and this will be auto-configured when you have a Spring Boot test with auto-configure MockMvc, or a slice test with a WebMVC test. So it configures both of them, so you can auto-wire any of them into your test. So here's an example where you have a test, right, with a Spring Boot test. You auto-configure the MockMvc, and then you get the MockMvc tester. So notice now that we can use AssertJ, right, when we test the endpoints. So you use the MockMvc tester to simulate a GET request to a particular URL, and then you have the expectations. You can check that the status is okay, that the content is in a particular MIME type. You get the body. You even can convert it into some kind of class or record, and then you can check that it satisfies a particular rule, right? So basically, MockMvc, right, supporting, right, AssertJ. But yeah, these are not all the features that are in a Spring Boot. Actually, there are actually much more, right? So for instance, we have a graceful shutdown by default. This is something that we already had for a long time, but now all the applications will have that enabled. We also have fragment rendering, right? That means that from an MVC controller, you can return more than one view, right? So especially for applications that use things like HTMX, where you can render multiple parts of your view, that's going to come handy, right? So we basically return multiple views so you can update, right, multiple parts of your view. You also have support for background bean initialization, fallback beans, right? So that's basically part of the core. We also have support for content negotiation in exception handlers. Now, more test containers improvements. So you go to the release notes of Spring Boot, you'll see that, well, we have a lot of things apart from the ones that we just covered. So I encourage you to upgrade, right? So upgrading will basically give you better performance, better startup times, just by upgrading the Spring Boot version and also the JDK version, right? Usually gives you a lot of a better performance. So you'll get new features, new security updates, and so on and so forth. So go to the release notes, check the migration guides. Usually in the release notes, the first thing that you'll see is the instructions to upgrade, right? So go there, check what has changed, the properties, the APIs that have been deprecated, test, and, well, get the latest bits and bytes. This is where Open Rewrite is doing a really nice job, right? So you don't want to spend a lot of time in the release notes, and probably you'll forget about some property, right, that has changed. So it's better to rely on tools like Open Rewrite. Open Rewrite has a lot of recipes, right, to upgrade to other versions, right? So we have recipes to upgrade to Spring Boot 3 for the ones that you are still in 2.7. Really helpful, especially that one with all the Jakarta migration and pain, right? But we also have already recipes for 3.1. 3.2, 3.3, and 3.4 is under the making, right? So still not out yet, right? So Spring Boot 3.4 was out in November, but we're still waiting, right, for the recipe, right, to update to 3.4, but it will eventually come out, right? So if you haven't upgraded to 3.4, right, that's going to be a good way to upgrade, right, to the next release. So looking to the future, right, Spring Boot 3.5, as we know, right, so every 6 months, right, it will come out in May 2025. And as we mentioned, this is still going to use the 6.0 branch of the Spring Framework, and this is going to be the last release of the 3. Whatever branch, right? And this won't contain a lot of like new features, but it's going to be a release, right, to wrap up the 3.0 story, right, and basically get ready for Spring Boot 4 and the new LTS, which still is going to be based on JDK 17, right? So you don't have to migrate into Java 21, but it will support JDK 25. It will have a Jakarta 11 as a baseline. It will have a Kotlin 2 as a baseline, support for JSpecify, and many other things, right? So new generation, right, of Spring Boot and a Spring Framework will come late in November this year, right? So, yeah, with this, I want to thank the Spring team for making our lives easier, right? So now you have Java 21 with virtual threads, with CDS, with all the observability, with build packs that creates these great containers with all auto configuration, simple abstractions. What can we ask more, right? So we have all the tools here to make it like a really good applications, right? Using the latest technology, and all thanks to the Spring team, right? So. Thanks, Spring team, right, for making our lives easier, and thanks everyone, right, for attending this talk, right? So with this, if you're a Spring fan, right, Spring IO might be the next place, right, for you, right, in May, right? So Barcelona, May, right, and Spring, it's a good combination. And if you have any questions, I'll be happy to take them.